Today we're going to start looking at geometric sequences. We're going to learn the definition of a geometric sequence. We're going to identify geometric sequences. We're going to know the recursive formula for every geometric sequence. We're going to know the explicit formula for every geometric sequence. We're going to find a given term of a geometric sequence. We're going to understand the geometric mean, and we're going to use the geometric mean to find the missing terms of a sequence. In 9.1, we learned about a different kind of sequences. For this section, we are going to be focusing on a specific kind of sequence. This type of sequence is going to be called a geometric sequence. Geometric sequences are any sequence that are formed by multiplying the previous term by the same number. That number becomes what's called the common ratio. So an important reminder that a geometric sequence with the first term of a sub 1 and a common ratio of r can be written as follows: a sub 1, r times a sub 1, r squared times a sub 1, and r cubed times a sub 1, etc., etc. So again, there's two different definitions. The recursive definition of every single geometric sequence has two parts. A sub 1 is equal to the first term, and a sub n is equal to r times a sub n minus 1, versus the explicit definition of every geometric sequence can be written as a sub n is equal to a sub 1 times r to the n minus 1. So looking at problem 1, we just need to be identifying geometric sequences. It says, are each of the following sequences geometric? If so, we just need to give the first term and the common ratio. Alright, so looking at A, I've got from 3 to 6. It's wanting to know if it's geometric, so that means I'd have to be multiplying by the same thing over and over and over again. So in order to get from 3 to 6, I'd have to multiply by 2. Getting from 6 to 12, multiply by 2. 12 to 24, multiply by 2, and 24 to 48, multiplying by 2. So, since I'm multiplying by the same thing over and over again, yes, this is geometric. The first term would be 3, and my common ratio would be 2 in this case. That's what I'm multiplying by again and again and again. Alright, on B, I would have to multiply by 2 to get from 3 to 6, and then from 6 to 9, I would have to multiply by, 3 halves, sorry. Took my brain a second. In order to get from 9 to 12, well, do I really need to do this one? No, because I already see that 2 and 3 halves are not the same numbers, so no, this is not geometric. Alright, and then finally, C. I would say, okay, I've got to get from 2 to 4, so I'm going to multiply by 2. 4 to 8. I'd have to multiply by 2. 8 to 16. I'd have to multiply by 2. And then 16 to 32. I'd have to multiply by 2. So yes, this is geometric. A sub 1 would be then just 2, and my r in this particular case is also going to be 2.